Hi students, this is Dr. J. Srinivasa Rao, Associate Professor in the Department of Electrical and Electronics Engineering. From the Electrical Circuit 2 subject, today I am going to cover these topics. First one is filters, second one is importance of filters, third one is types of filters, fourth one is basic filter circuit. Today I am going to cover these four topics. This is the definition of the filter. A filter is a circuit that is designed to pass signals with desired frequencies and reject or attenuates other frequency signals. So this is the definition of the filter. Before we are going to discuss about this filter definition, I will tell you one example. So based on that example, we can understand definition of filter. Suppose, just assume that I have 6 chocolates. I have 6 chocolates with different branded, like different companies. One is 5-star chocolate, and one more is Kit Kat, one more is Dairy Milk. Like that, 6 chocolates are there with different brands and different company names. Now, I have to choose one chocolate out of 6 chocolates. So these are the 6 chocolates. I have 6 chocolates, but I have to choose, or I have to pick only one chocolate out of 6 chocolates. Now, so I will pick one chocolate, so that is called 5-star chocolate, as I am liking this chocolate. So I have chosen this chocolate. This is 5-star chocolate. Why I have chosen this chocolate is I am liking this chocolate. That is why I have picked this chocolate. Right now, so what is the name of this entire process? This entire process nothing but filtering process. I have to leave all remaining chocolates except this 5-star chocolate, as I am liking this chocolate. So this process nothing but filtering or filtering process. So this is the simple definition of filter. Now if you go to this filter circuit, this is the filter. Input side, we will give some signals here. Output side, we will be getting some signals here like this. Right, just assume that input side 10 Hz frequency signal is available, and 15 Hz frequency signal is available, and 20 Hz frequency is available, and 50 Hz frequency is available. Right, now we have input side 4 signals are available with different frequencies, multiple frequency signals. Right, now output side, so desired one is only 50 Hz. Desired one is 50 Hz. Now in this case, this filter circuit, what this filter circuit is doing, now this filter circuit allows the or pass the 50 Hz signal, as this is desired one. Input side, number of signals with the different frequencies are available, but out of 4 signals with the different frequencies, now it passes the only 50 Hz signal. Now this is called desired one. So if you go to the filter definition, a filter is a circuit. This is a circuit that is designed to pass signals with a desired frequency and reject or attenuates other frequency signals. Now out of 4 signals, this filter circuit allows the only 50 Hz, as this is desired, and it rejects or attenuates 10 Hz frequency signal, 15 Hz frequency signal, 20 Hz frequency signal. So this is the simple definition of filter. It passes the signals with the desired frequency and reject or attenuates or stops the other frequency signals. Now this is called filter definition. Now second one is we look into importance of filters. So number of applications are there. So I will give you one example regarding this importance of filters. So we have telecommunication companies like Airtel company and Jio company and a Vodafone. So number of telecommunication companies are there in India. Now I have considered Airtel company is first one and the second one is Jio company. What these telecommunication companies like Airtel and Jio companies are doing? Now what these companies are doing is they buy spectrum from the government. Now what is the meaning of spectrum? Spectrum means range of frequency. Spectrum means range of frequency. Now I have considered 100 to 200 hertz frequency. Spectrum means range of frequency. Now coming to Jio, Jio also buy spectrum. The spectrum range is we can assume 50 to 75 hertz. Right? What is the meaning of buying a spectrum from the government? Spectrum nothing but frequency range. I have considered spectrum range for Airtel is 100 to 200. For Jio company, spectrum range is 50 to 75. Now, so buying nothing but, so this Airtel company and Jio company will send their signal through air. They are utilizing the air to send the signal. So just like that, we can use the air to send the signal. So we have to get the permission from the government. So that is called buying of spectrum from the government. In government auctions, these telecommunication companies are buying spectrum from the government. Example, I have given 100 to 200 spectrum for Airtel company. They will send the signal with a range of 100 to 200. And Jio company, they will send the signal through air, the frequency range 50 to 75. So this is called buying of spectrum from the government in government auctions. Right. Now, what is happening? Okay, they're buying spectrum from the government. Now, what is happening here? Airtel company will build their own tower, Airtel tower. Now, this is Airtel tower. So, if you observe the towers in cities or outside the cities, some signal towers are there. So, these are signal towers of Airtel or Jio towers. Now, Airtel company will build their own tower, that is the Airtel tower. Similarly, Jio company also will build their own tower, signal tower, that is Jio tower. Now, what is happening? This Airtel company will send their signal with a frequency 100 to 200 through the air like this. Now, these signals will be circulated in the air and reach what? Airtel tower, signal tower. Similarly, Jio company also will send their signal in the air at the frequency range 50 to 75, and these signals will be circulated in the air and reached Jio signal tower. And signals will go to the any tower, signal tower through air. Now, this Jio signal will go to this Airtel tower. Similarly, this Airtel signal will go to or will reach Jio tower. Now, at each tower, there are two signals are available. One is Airtel signal and one more is Jio signal. Now, Airtel tower has to accept or pass the only Airtel signal. But here two signals are available. That is why now we have to keep one circuit. This is called filter circuit. Now, what filter circuit is doing is, this filter circuit filter the signal. Here two signals are available. One is Airtel signal and one more is Jio signal. Now, this filter circuit accepts or passes the only Airtel signal, as this is Airtel tower. Now, it does not allow the Jio signal. Why? Because the spectrum range is 100 to 200. The spectrum range of Jio signal is 50 to 75. Now, this filter circuit allows the 100 to 200 range signal and rejects the 50 to 75 frequency signals. So this is the importance of the filter circuit in telecommunication engineering. Similarly, at a Jio tower, there are two signals are available. One is Jio, the range is 50 to 75 frequency range hertz. And one more is now these signals will be circulated in the air. The range of the signal is Airtel signal 100 to 200 hertz frequency signal. Now again we need to design one circuit. This is called filter circuit. Now this filter circuit of Jio will filter these two signals. As this one belongs to Jio tower. This filter allows the only Jio signal, that is 50 to 75 Hz signal, and it attenuates or rejects this Airtel signal. So this is the importance of filter circuit. Now sometimes what is happening, whenever we are calling to our friends, our parents, or someone else on phone, suddenly some other call gets connected. So this is happening due to signals will be mismatched in the air. So if there is no proper circuit, filter circuit, if there is no proper operation of the filter, what is happening? So this thing will be happened. So signals will be mismatched. That is why we can hear two voices in the same call or one call. So this is the importance of the filter circuit. Just now I am talking about only telecommunication engineering application of filters, but similarly antennas, TV antennas, radio frequency, number of applications are there. I told you only one application, right? This is about importance of filter. Now we will look into, let us move to third one is types of filters. So basically filters are classified into two types. One is passive filter, second one is active filter. Passive filter consists of passive elements. Passive filter consists of passive elements, and active filters consist of active elements. Passive element nothing but which consumes energy. Examples resistor, inductor, and capacitor. Active filter consists of active elements. Active elements nothing but which delivers energy. So examples of active filters: operational amplifier and transistors, op amps, operational amplifier and transistors. So these are the examples of active filters and passive filters. Now today we are going to discuss about only passive filters, types of passive filters. So this is our topic, passive filters, types of passive filters. Again, passive filters are classified into four types. One is low pass filter, second one is high pass filter, fourth one is band pass filter, third one is band pass filter, fourth one is band stop filter. Now we will go by one, low pass filter, high pass filter, band pass filter, band stop filter. First of all, we will look into low pass filter. Low pass filter, a low pass filter passes low frequency signals and rejects high frequency signals. The name of the low pass filter itself is telling that it allows it passes the low frequency signal, low pass. It passes the only low frequency signal and it rejects or attenuates the high frequency signal. See there here, low pass filter. So input side, any filter we will give input side we will give signal, and we will be getting output side some signal, desired signal, right? Now just here 0 frequency, 0 hertz signal is available input side. 10 hertz frequency signals are available input side, like 15 and 15 hertz and 20 hertz and like that 50 hertz. So these signals are available, and 60 hertz signal is available. So these are the signals available on input side. Now what is happening here? As this one is low pass filter has to pass the only low frequency signal. Now I will consider, so these are the low frequency signal. These are the low frequency signal. Now I will consider the coming to 50 hertz and 60 hertz. So these are high frequency signal. I will consider like that. I am considering like that, high frequency signals. Now, so as per the definition of low pass filter will allow pass only low frequency signal. Now coming to this side, input side, I will consider this is low frequency, low frequency, low frequency, low frequency. Now this low frequency signal allows only low frequency signal and does not pass or attenuates or rejects high frequency signal. Now, so this is the diagram. Now here HW nothing but this is voltage gain. This is voltage gain, or we can call transfer function. Transfer function. Now this value is equal to output voltage by input voltage nothing but voltage gain. Right? This is the output of the filter. This is the output of the filter. Right? Pass band nothing but 0, omega is equal to 0. This is the 0 frequency, and omega c is equal to cutoff frequency. This is the margin. Right? Now I am taking omega c is equal to 20 hertz, and this is omega is equal to 0. Now what I have considered 0 hertz and 10 hertz and 15 hertz and 20 hertz. I have considered these frequencies as low frequency signal. That is why this low pass filter allows all frequencies 0 hertz, 10 hertz, 15 hertz and 20 hertz. Now it allows all the signals. And coming to what 50 hertz and 60 hertz, so these are comes under high frequency signal. That is why filter does not or rejects the 50 hertz signal and 60 hertz signal. So finally what I want to conclude is low pass filter allows the only low frequency signal and rejects or attenuates high frequency signal. If you go for this diagram, now see there here what is happening here from 0 to and 20 hertz. Now here this one is equal to 1. Voltage gain is equal to 1. Now voltage gain is equal to 1. Now output will be there. From 20 to more than 20, now more than 20 nothing but here 50 is there and 60 is there. For 50 Hz frequency and 60 Hz frequency, it does not allow this signal and this signal. That is why voltage gain H omega is equal to 0. Now we can differentiate between pass band and stop band. Whenever voltage gain is equal to 1, this is called pass band. In the pass band, what is happening? Signal will be fast like this. Whenever gain is equal to 0, so this is called this band nothing but stop band. It does not allow signals. It does not allow signal. So this is the difference between pass band and stop band based on this omega, the gain value, H omega value, voltage gain value. So this is about low pass filter. Now we'll move on to second filter, high pass filter. High pass filter passes high frequency signals and rejects low frequency signals. Now this is high pass filter. This operation is completely opposite to what? Low pass filter. Low pass filter allows or passes the low frequency signal and rejects or attenuates high frequency signal. But coming to high pass filter, it passes the high frequency signal and stops or rejects low frequency signal. So this operation is completely opposite to low pass filter. Let us see what is happening here with the help of the circuit diagram. Now again here, frequency input side, number of signals are available. 10 Hz frequency signal, 20 Hz frequency and 30 Hz frequency and 40 Hz number of signals are available. So these are I will consider these are low frequency signal. Low frequency signal. Now here 50 is there, 60 and 70, these are what? High frequency signal. I will categorize these signals into two groups. One is low frequency, one is low frequency, one more is high frequency signal. High frequency signal. Right. Now coming to what? This high pass filter. High pass filter passes high frequency. That means 50 Hz, 60 Hz and 70 Hz. Now here it allows it passes the 50 Hz, 60 Hz, 70 Hz frequency signal. As These are high frequency, comes under high frequency signal. Now coming to low frequency, now these are the low frequency range. Those 10 and 20, 30 and 40, these are what? Low frequency signal. Now high pass filter stops or rejects this signal, low frequency signal, and passes this high frequency signal. So this is the operation of high pass filter. Now if you go for gain, voltage gain value, now in stop band there is no signal passing. In pass band there will be a signal passing. In stop band, what is happening here? Now voltage gain value is equal to 0. That no output for low frequency signal. For a high frequency signal, now what is happening here? High frequency signal, so output will be there. Output is equal to 1. Now here in the zone, what is happening here? Output is equal to 1, gain is equal to 1. Now finally what I want to conclude is, high pass filter allows or passes high frequency signal, rejects or attenuates low frequency signal. This is completely opposite to low pass filter, right? Now let us move on to third one, band pass filter. Band pass filter passes frequencies within a frequency band and blocks or attenuates frequencies outside the band. Here band nothing but range of frequency. Here omega 1 is one frequency and omega 2 is one more frequency. Right, just assume that here I will give you some input signals, input side of the filter, like 0 hertz, 10 hertz and 20 hertz and 40 hertz, like this. Now one more 50 hertz, this is one more frequency signal. Now I am taking, this is called omega 1, and after that 60 and 70 and 80 and 90, and similarly last one is 100 hertz. After 100 hertz, again 110, 120, these are the input signals available, inputs of the band pass filter. Now if you consider, we have taken omega 1 is equal to 50 hertz and omega 2 is equal to 100 hertz. So this is the band in between 50 hertz and 100 hertz. What is happening in band pass filter is, this filter allows the certain band of frequencies. Now here if you consider all signals, now in between omega 1, 50 hertz and 100, so these are the signals 60 and 70 hertz, 80 and 90. Now what is happening here? Now this band pass filter allows the only three signals in between, the frequency range is there in between omega 2 and omega 1, that is 50 to 100 hertz frequency. Now this band pass filter allows this signal only, and it does not allow the remaining signals. Remaining signals means less than omega 1 and greater than omega 2. That means it does not allow the 0 frequency signal, 10 hertz, 20 hertz and 40 hertz. Why? Because these are under less than omega 1. Similarly, greater than omega 2, that is 100 hertz, what are the signals are there? Like the 100 hertz, 120 comes under in the zone 120 and 110. Now it rejects this filter rejects the 110 hertz frequency signal and 120 hertz frequency signal. So in between band omega 1, omega 2, that means 50 hertz and 100 hertz, it allows a signal. That's why this is called band pass filter. In between certain band of frequencies, that means in between omega 1, omega 2, it allows the signal. That means it passes the signal. And outside of the band, it does not allow. That means it rejects the signal. Now, if you go for gain value h omega, this is 0 for stop band filter. Now less than omega 1, what is happening? The gain of the filter, this one is 0. Here also stop band, the gain of this filter, output of the filter is 0. Why? Because this is stop band. Here there is no passing of signals here. There is no passing of signal here. That is why gain is 0, gain is 0. In between omega 1 and omega 2, it passes signal. That is why the gain of the filter or output of the filter h omega is equal to 1. Now this is about band pass filter, right? Now let us move on to fourth one, band stop filter. This band stop filter operation is completely opposite to band pass filter. What happened in case of band pass filter? In between frequency band omega 1 and omega 2, band pass filter allows the signal. That means passes the signal. But here what is happening? In between omega 1, omega 2, this frequency band stop filter not allowing the signal. That means it is rejecting the signal. That is why here stop band is there. But in case of band pass filter, so instead of stop band, pass band was there. Right? Again, I will take some signals input side of the band stop filter. We will see what is happening in between omega 1, omega 2. Let us see what is happening less than omega 1 and what is happening greater than omega 2. Again, I will take same input signals here. 0 Hz frequency input side, 10 Hz, 20 Hz, 30 Hz, 40 Hz. Now again 50. Now I have taken 50 is the omega 1. Again 60, 70, 80 and 90, 100 and 110 and 120. So these are the input signals available at the input side of the band stop filter. Let us see what is happening here. Now, so these signals up to 0 to 50, so these signals comes under low frequency signals. Or we can take these signals are less than omega 1. Now what is happening here? So here these signals are there input side. Now this band stop filter allows the signal less than omega 1. See there what is happening here? Less than omega 1. Now all signals will be passed through the filter like this. This is pass band. Now after 50 omega is equal to, we have taken 50, right? And omega 2 is equal to 100, right? We have taken an example like this. Now what is happening in between omega 1 and this is omega 2? What is happening? Now this is the frequency range. Now coming to band stop filter, what it is doing is it stops the passing of the signals through filter from omega 1 band to omega 2 band, omega 1 band 2 and omega 2 frequency. It's a frequency range. So in between omega 1, omega 2, what are the signals are there? 50, 60, 70, 80, 90, 100. These signals comes under in between omega 1, omega 2 band. Now band stop filter does not allow the signal. It blocks the signal passing or it rejects the signal passing. That is why here stop band is there. So this is happening in between omega 1, omega 2, and let us see what is happening after omega 2. Now omega 2 is called 100. Now what are the signals are there after 100? After 100, 110 Hz signal is there and 120 Hz signal, one more signal is there. Now this is 110 and this is 120. These are comes under after omega 2. These are the signals greater than omega 2. Again, this same band stop filter allows the signal. Right? Now what I want to tell you is, in between band omega 1, omega 2 or band frequency omega 1, omega 2, in between 50 and 100, it stops the passing of the signal. Less than omega 1, that is less than 50 Hz and greater than 100 Hz, again it passes the signal this side and this side. So this is the main principal operation or main point of the band stop filter. Right? One more point is in terms of gain H omega is equal to 1 for less than omega value. Now for less than omega 1 value, now less than omega is equal to, we have taken 50 Hz. For this case, H gain is equal to 1. Output side of the band stop filter is H omega is equal to 1. Output is there. From in between omega 1 to omega 2, what is happening? Again, say output of the filter is equal to, gain is equal to 0. Why? Because here stop band is there. It does not allow the signal. Again, greater than 50, greater than omega 2, that is greater than 100. What is happening here? Again, this filter allows the signal. Now, what is happening again? In this after omega 2, again, this gain value is equal to, output of the filter is equal to 1. Now again output of the filter is equal to here 1. So the output of the filter for less than omega 1, that is less than 50 Hz, 1 value, greater than omega 2 value So output of the filter is one value. In between omega 1, omega 2, now output of the filter is 0. So this is the point to be observed in this case, right? This is about types of filters. The operation of the each filter is different. The operation of the band stop filter is completely opposite to band pass filter. Similarly, the operation of the high pass filter is exactly opposite to low pass filter. So this is about all types of passive filters. Last one is this slide gives the complete picture of 4 filters regarding the output of the filter. Now this is low pass filter, this is high pass filter, this is band pass filter, this is band stop filter. So based on this gain value, we can say that this is stop band zone, this is a pass band zone. Already I told you, right? Here see there, this is low frequency signal. Whenever this is infinity, nothing but high frequency signal. Omega 0 nothing but we have categorized it into low frequency signal. Infinity nothing but high frequency signal. Now what is happening? Low pass filter allows the low frequency signal. That is why so gain is equal to 1. Low pass filter rejects the high frequency signal. That is why gain is equal to 0. The coming to high pass filter allows the high frequency signal. That is why gain is equal to 1. High pass filter does not allow the low frequency signal. That is why gain is equal to 0. When gain is equal to 0, stop band. When gain is equal to 1, there is a pass band. So this is the difference between gain value 1 value, gain value 0 value, right? And coming to band pass, so band nothing but range of frequency. Now what is happening in case of band pass? Now this is the omega 1, this is one more range omega 2, right? Now what is happening for low frequency gain is equal to 0. That means what is happening in this case, low frequency, now here gain is equal to 0. Again, though infinite nothing but high frequency, this is greater than omega 2. Again in this stop band, now here gain also 0. Right, in between omega 1, omega 2, this band, in between this one, omega 1, omega 2, this is the band, right? Here, pass band, this is the pass band. Now here, h omega is equal to 1. This is pass band, this is stop band, this is stop band. Right, similarly, band stop filter, this is exactly opposite to band pass filter. That is why, now what happens, see there, now this is, again this is 1, omega 2. For low frequency signal, this is a low frequency signal. Now what is happening here? Gain is equal, output of the filter is equal to 1. And again after omega 2, what is happening again? What is happening here is, again it passes the signal. Now here h omega is equal to 1. So after omega 2, that means infinity nothing but high frequency signal. So after omega 2, this one comes under high frequency signal. That is why output of the filter is there 1. For low frequency signal, this is the low frequency signal less than omega 1. Again here it passes a signal. That is why here gain is equal to 1. Here gain is equal to 1, gain is equal to 1. In between omega 1, omega 2, what is happening? This is stop band. That means gain is equal to 0. This slide, last slide, gives the complete information about all the operational points of the four filters: low pass filter, high pass filter, band pass filter, and band stop filter. Right? This is about the complete information of what is filter, what is the importance of filter, and what are the types of filters, and regarding gain value, what about operation of each one. Right? Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.